So now we are given this circuit. Notice the switch is open at t equals to 0. When it hits t equals 0, it's going to close, going to make contact. So we will have a source for t greater than 0. That's the first time here. So if I look at the circuit for t less than 0, if you remember from the previous video, that's the first step. Look at the circuit for t less than 0 and calculate the voltage across the capacitor as 0 minus. Which is what?
What does that mean exactly, the 0 minus?
Like before the switch, t equals 0, that's the time you close it. So when you go to the lab and you move that switch, that's the 0 time. So right before that, before you move that switch, what was the voltage right there?
120. Before you close it?
It will be 0. There was nothing in the circuit. There's no source, right? This is not connect. Which means the voltage across the capacitor is 0 plus. Right after you move that, you take that lead and you connect it right there. Once you connect it, at that time, that voltage didn't change yet because it doesn't change in 0 time. I equals, this is I equals C dVc dt. That tells me the voltage does not change in 0 time. Yes?
So we can always make the assumption that Vc 0 minus equals
Always.
same as Vc 0 plus.
Correct, always. And that's because of that equation. So now what happens at t greater than 0? The switch moves over. And by the way, I can take these two resistors, combine them together. What's 500 and 2,000? The product over the sum. 500 times 2,000 divided by 2,500. It's 400 here. The result of these 400 plus the 600, that will make it what? 1,000. Bless you. Bless you.
Thank you.
And I almost made the mistake saying let's do source transformation. I can't. That's a voltage source in parallel. I can't. It has to be a current source in parallel with that to do source transformation. I know the voltage here is what? That's 120 volts. I know the voltage here is what? VC. If I call this VC. Let's look at this node and let's assign current. Let's say there's a current this we'll call IC. There's a current down this we'll call R1. We'll go I1 instead of IR1. That'll be too much. We'll go I1. And we want this current going in or out. Doesn't really matter. Out. I2. So IC, I1, I2. I use capital letter because my eyes look like a C there. Notice it looks like a C, so I try to avoid using lowercase. Yep. So if I use capital letters, easier. We can do KCL at that node. It says if you add all the current going into that node is equal all the current coming out of that node. What is going to that node? Nothing. What is leaving that node? I see this current here. I equals what? C dVc dt plus I sub 1, notice it's coming down, It's VC minus nothing over 1250 plus this one, which is what? Is going to the right, VC minus 120 over what? 250. Now, let's multiply by 250, and C, by the way, is 4 micro. So let's multiply everything by 1250. And what's 1250 times 0 is 0. What's 1250 times 4 micro? Let's see. 1250 times 4 micro. 0.005. Plus VC plus, is that a 5? 5 VC minus, what's 5 times 120? 600. Clean it. $600 equals 0.005 dVc dt plus what? 6 VC. Divide by 0.005. What is 6 divided by 0.005? 1200. And this will be what? 120,000, I think. Okay, now I look at the equations I gave you last time. That looks like the second equation. You have a constant now. It's no longer 0. So the equation I gave you says if you have an equation that looks like this, then the solution will be A over alpha plus K e to the minus alpha t. We'll compare the two of them. My alpha is what? 1200, and my A is what? 120,000. So my solution, the voltage as a function of time, should be 120,000 over 1200 plus K e to the minus 1200 t. 120,000 divided by 1200, is that 100? Yep. That's the voltage across the capacitor at any given time for t greater than 0. The only problem with that is what?
Don't have your K value?
K. I need to know what K is. We know the value is 0 plus. What was the voltage of 0 plus?
0.
0. Let t be 0. We said the answer is 0, which is equal to what? 100 plus K e to the 0. 0 equals 100 plus K. What is K equal to? Negative 100. So what's the voltage across the capacitor at any given time for t greater than 0? It's 100 minus 100 e to the power of negative 1200 t. again, if you were watching that value, it will look like this. Has initial value of 100 the voltage. Then it's going to decrease like this. And we can calculate how long would it take to reach 0.1, 0.2, whatever value you want to use, using trig there.
Wait, so why exactly is it for when it's t is greater than 0?
Is what?
That's the function for when
The voltage cross 0, was it 0? Oh, 0, 0, I'm sorry, not, it was 0, not. VC as 0 minus was a 0, right?
yeah, and for isn't it also 0 plus?
At that instant, then it jumps up. Notice when t equals to 0, what's e to the 0? Oh, actually, this one will be the reverse. This, the capacitor will charge. Uh-oh. This actually, because I forgot, this actually we have a source for t greater than 0, not before 0. Uh-oh. There we go. So this one actually will look like this. At 100. Backward.
Is that because time can't be negative?
Well, time can't be negative, so as you approach infinity, what's e to the minus infinity? 0 times 100, 0. What's 100 minus 0 goes to 100. But it's not going to take infinity time. It's going to take probably about 2 seconds, 3 seconds before, or even less than that, before it hits like 95, 96. I can calculate that value. But the voltage before that was 0, then start to increase exponentially. Notice that t equals 0. This is e to the 0, 1. 100 minus 100, that's 0. At t, for example, equals 0.5 seconds. .5, what's that, negative 120? Look at that. It's almost 100, right? What is e to the negative 120? Where'd you go? E. Turn it on. And the value is actually 100. Because that number at 0.5 second, that value is 7.66 times 10 to the minus 53, the value of this one. Big Z, that's a 0. Negative 53, that's a 0. So it takes less than 0.5 second to go up. It probably takes less than 0.100th of a second. What is the 100th of a second? What's the value? If you do, it's going to be 100 minus 100 e to the power of negative 12. $99.999, right? So we're not talking about a long time. We're talking about million microseconds for that capacitor to react as a source there. It charges to that number, then it becomes a source of like 100 volts there.
What happens with the current? It's like a jolt of current, right? When you hook it up, when you connect the switch.
Well, if we calculate the current, I equals the derivative of this. Notice that's e to the power. So the current's going to have the same look there. That's the equation. What's the current going through the capacitor? The question, what is that current going to look like? This is I. C dVc dt. And what is C here? C for this problem, 4 micro. What is the derivative of 100?
0.
What's the derivative of e to the negative 1200?
120,000.
Negative another 1200 e to the negative 1200t. So minus times a minus, that's a plus. What's 120,000? Times 4 micro. Uh-oh. Can't be right. 12,000. I mean 120,000, I'm sorry. Times 4 micro, I get some big number. 0.48 now, that makes more sense. So if you're watching the current there, you asked me if it's going to be a jolt of current. Initially, there was nothing going through the circuit because there was no source, right? But once that value goes to 0, that current jumps to 0.48 amps. Then it's going to decrease like this, because that's e to the negative power.
I don't understand why it decreases when the voltage is increasing. It reaches that.
Well, that's the current is decreasing, the negative exponent. Why the voltage is increasing? Because this value, that's what the voltage is going to be, because that source, the 100 ohm source there, 100 volt source here, where's that circuit? Now you get two sources in the circuit. You got this guy, you know? So what's going to happen, this is going to react as a source of the value of 100 minus that. This value actually, as the time increases, this value decreases. When the time is 0 or very close to a small number, for example, if let's say we use 1 millionth of a second, 1 microsecond, plug it in here, that's 100 minus 100 e to the power of negative, what is 1200 times, was it 1 micro? That's negative 0.0012.
It's because the capacitor stores energy at a big rate, so it's not. So the current's not going to be flowing through it. It's going to use.
And what we have is 0.1 volt. It isn't that. So that value here of the capacitor, that voltage is going to start low, start to increase, but it doesn't take long a time for it to reach 100 volts. It takes less than 1/100th of a second. And now this will stay 100 volts after that the entire time till you disconnect that source. Because this is going to behave as an open circuit. If you do an open circuit, what do you have? You have a voltage division here. This is gone. The voltage here is the same voltage as right there. So we take 120 times 1250 over the sum of them. And I bet you if we did the math, if we do the math, 120 times 1250 over the sum of them, tell me if that's 100 or not. Does that equal to 100? I won't even do the math. I'll let you tell me if that's 100.
Yeah.
Yep, because that's going to behave as an open circuit. For a few milli or microsecond, we can't neglect that, and that's where the problem is. We want to neglect it, but we can't. It's going to charge, but it doesn't take long. 1/100th of a second, 1,000th of a second for it to charge. Then it becomes like a DC source. This one DC source. This one reacts as an open circuit. It's not even there. Let's try another one. Yes.
So at the end of that problem, we made BC 0 plus equal to 0.
Minus, yep.
Which is equal to 100 plus KE.
Yep.
You made negative 1200 T equal to 0.
Yep, because T is 0. What's e to the 0?
Well, 1.
1.
Right, but like, why did you initially make T equal 0? Because isn't it equal
'Cause-
to 0 plus?
Yeah, go ahead, use 0 plus, 0.000000001. Right? Use that number. You have VC 0 plus equals, I said 100. You say, well, why use, we said 0, which is 100 plus K e to the power of negative 1200 times T. I said, if you let T be 0, so well, it's not 0, 0 plus. Okay, it's more than a 0. So let's see. So it's not really a 0. So let me put this number.
So as long as it's relatively near 0.
Yep. Put that number in. What are you going to have? Almost e to the 0. That number is so small.
Oh, because any number past 0.
So that number is going to be a 1. K equals negative 100. Just like when you do the limit. Remember the limit? We say, what's the limit of x squared minus 4 over x minus 2 as x approaches the 2? Well, if you let x be 2, there is no limit there, because you're dividing by 2. Over 0 over 0. So what do? You can use the table, look at it from the left side, the right side, 1.99999, and 2.001, 2.0001. Keep looking at it closer. Or you can just simplify this and go, you know what, if I factor the top, this will be x minus 2x plus 2 over x minus 2. Now you try direct substitution, the answer is 4. That's the same thing. I'm saying as t 0 plus, are you going to put 0.0000001? No, we'll put 0 and do the quick math that way.
That makes a lot more sense. Thank you.
You're welcome. Let's try another one. Now, while I'm at it, a lot of times they don't want to draw these switches. People get aggravated. The switch open, the switch close. So then what do? We're going to talk about a function called unit step function. While we're at it, so instead of doing the switches, it's called unit step function. And we call it u sub t. And the unit step function has a value of 0 for t less than 0. It has a value of 1 for t greater than 1.
Transistor then?
What do you mean like transistor?
Like 1 or 0 on or off?
Well, the only reason we're doing this actually, I know you're thinking on, off, but 0, 1. We can make the value 5, 6 if you put 5 times that, 3 times that. But the only reason that we use this one, so when I have the previous circuit, when you looked at it, instead of drawing that and have the switch there, was it 4 micro? What was that? I forgot what the circuit looked like. It was 1250 here, right? Instead of having a switch now, we go plus to minus. And instead of 100, we go 100 u sub t. Was it 120 in that previous one? Yeah, whatever it was. And we had what? 600 on the top. And what? 2,000 and 500. That's what we had. So This one says if your value is 120 u sub t, well, for t less than 0, what's the value for t less than 0? What's 120 times 0? Bless you. There's no source in it. And what happens for t greater than 0? What's the value of that?
Switch is closed.
That's the 1. So what's 120 times 1? You have a 120 volt source. So instead of having the switch there open, closing, all that, we use that. Now, in the previous examples from the previous video, the switch was opening or closing or moving at t equals to 0, right? It was connected, then you have no source after that. Well, if you want to do that, you can do u sub negative t. What's u sub negative t? That's a switch that has a value of 1 for t less than 0. Then it goes to 0 for t greater than that. If you want to put a 5 volts, you go 5 u sub t. 7 volts, 7 u sub t. So you will see us from now on, instead of using switches and connecting, so the switch open, closes, we just use that function to replace that. Let me take a problem. So let's look at this one. $50 volts, and I have another source here, and let's see the value of this. 50 u sub t. Two ohm, six ohm, and let's have an inductor here of 3 Henry. And now I want to find the current through the inductor. What's the current?
1 over L.
Now, for inductor, V equals L di dt. Or L equals 1 over V, the integral from negative infinity to t, I dt. What did I say? I equals. Oh, God. I equals 1 over L. Ooh. Boy. 1 over L, the integral of V dt. I got to go back to bed. The Patriots are killing me. Watch them
So you
till...
get a free coffee.
I know. Why? Because they won?
Yeah.
From where?
Dunkin' Donuts.
Really?
Mm-hmm.
I didn't know
You
that.
have the app, but yeah. Dunkin' Donuts.
So if you have the app, you can get free
Yeah.
coffee?
Every time they win?
Yeah, every time I went.
Gee,
Wait,
I missed
we'll
12.
all go.
I missed 11 cups of coffee already?
Yeah.
Yeah.
Dad, you drink coffee all the time.
Yep. Is it a certain time?
No, it's all day.
Really?
It's just the day after.
Oh, shoot. We could have 10 cups of coffee free today. There's my app.
Yeah, there's Dunkin' right down the street. Oh,
Oh, I didn't know
yeah.
that.
Right after.
I'm not happy now. Okay. So for t less than 0, for t less than 0, what's the voltage here?
0.
That's a 0
It's always 0, right? Am I correct?
for u sub t, yes.
What's the point of it then?
Well, it's like a switch.
Oh.
This is like have another source there, adding to that at t equals to 0, second source.
Okay.
So for t less than 0, that source is 0. And you have a 50, 2, 6, 3 Henry, and I'm looking for the current. And I'm assuming actually that this source been here for a while. If that's the case, what's going to happen to the inductor? Inductor behaves as what to DC? Short circuit. So if you put a short circuit there, what is the current through that? Would any current go through the 6 ohm resistor?
It's the division of whatever the current is through the 2.
No. That's a short circuit.
Ow! So yes.
Nothing will go through this one, so your circuit will look like this.
It's whatever's through the 2.
So Ohm's law, Isabel says the voltage 50 divided by 2, which is what? 25. So the current through the inductor is 0 minus, which will be the same as the current through the inductor is 0 plus, is going to be 25 amps. We're going to need that later to find K. Let me box it. I'm going to need it.
Wait, so why was it reduced to just 2? Oh, is that one?
Current will take the least resistive
yeah,
path.
That's right, okay. I got you.
So now for t greater than 0. Now that source on the top, now you can't ignore it. You can have a 50 and a 50 here. So now we have a source, 2 sources here. I can combine them together and make it 100. I can do source transformation. 100 divided by 2, which is what? 50. Two and 6 in parallel. $300. Two and 6, can I simplify that? That's 8, 2 times 6, 12. 12 divided by 8. Is that 1.3? 4 over 3? So if I'm looking for the current through the inductor, I need to be doing voltages here, KVL, because some of the voltage in a closed loop is 0, and the voltage is L di dt. So I'm going to do source transformation one more time. What's 50 times 4 over 3? Is that 200 over 3? So if I make it one loop here, this is I sub L. Sum of the voltage in a closed loop is 0. Negative 200 over 3 plus 4 over 3 times I sub L plus, what's the voltage across the inductor? L di dt. L is what? 3 di dt. When I say I, that's I sub L. Equals 0. Multiply by 3 to get rid of the fractions and clean it. Or actually divide by 3 and clean it. If you divide by 3, what do you have? Di sub L dt plus, is that 4 over 9? If you divide by 3, 200 over 9. I divided by 3. Well, that looks like the format we know. So I sub L is going to be A over alpha plus K e to the minus alpha t. My A is 200 over 9. My alpha is 4 over 9. E to the minus 4 over 9t.
So that's just 50.
That's a 50, yep. So now if I can solve for k, I am done. I said there's a value we did earlier for t less than 0. We said the current at 0 plus is what? 25 is equal to k, 50, not k. It will be k shortly. It'll be 50 plus k e to the power of 0. I can use 0.000001. I'm not. E to the 0 is 1. 25 equals 50 plus k. What's k equal to?
25.
Negative?
Negative.
So what is the current through the inductor at any given time? For t less than 0 or greater than 0? 50 minus 25 e to the power of negative 4 over 9t. This is u sub t. What that means, this is for t greater than 0. For t less than 0, we know it's 25. So if I graph the current through the inductor, for t less than 0 was 25. The voltage does not change in 0 time, so at t equals 0, it's still going to be 25. But let's watch this. As t becomes infinity, big number, what is e to the negative infinity? E to the negative infinity?
0.
0. Times 25, that's 0. What's 50 minus 0?
50.
And that's the current, if you graph that, that's the current through the inductor for t at any given time, for t less than 0 and for t greater than 0. If you want to find the voltage, V equals L di dt. You take the derivative of that, and you can figure out what the voltage across that.